Okay, so for the following transfer function, we have to plot the Bode plots. So first thing we need to do is have everything be added by 1 instead. So we need to make this 2 be 1 and this 10 be 1 as well. So what we're going to do is factor out a 2 and then JW 10, JW over 10 plus 1. Okay, and then that this becomes 10 JW over 2 plus 1, 10 JW times JW over 10 plus 1. This and this are gone. Okay, now next we do is take log base 10 of all of this. This will give you your decimal equation. So log JW over 2 plus 1 minus log JW minus log JW over 10 plus 1. Now let's get our phasor formula. So we take tan inverse of the real component all over the imaginary component all over the real component. So this one will just be W over 2 minus tan inverse W minus tan inverse W over 10. Now to plot this, we're going to be using the following sheet. It's best to memorize this sheet, but pretty much but for now we're just going to be using this. So pretty much whatever our equation matches the equation with respect to this, that's what our plot will look like. So let's set up our decimal magnitude versus frequency plot. This will be HDB. This will be our omega. So this is in decibels, and this is in radians per second. So what we're going to do is first plot this one, JW over 2 plus 1. So we see this formula matches it, and we see at point Z, which is this point, which is whatever is being divided by JW, our thing is going to break and have a slope of 20 decibels per decade. So notice it's not in decibels per radians per second. Decade pretty much means increased by a factor of 10. So if we have 1 and it goes 1 to 10, that's 1 decade because increased by 1 factor of 10. If we have 10 to 100, that's 1 decade because it increased by a factor of 10. If we go have 1 to 100, that's 2 decades because increased by 2 factors of 10. So I'll get to how that all works, but for now, we know at point 2, we have a slope. Sorry, we have a graph that breaks and has a slope of 20 decibels per decade. Okay, and this will be represented by log JW over 2 plus 1. All right, next. Now we have minus log JW. So if it's a minus, we'll have to use the ones that are 1 over, okay? Because n is to the power of minus 1. So we see the closer one that matches will be this one. And we see that it intersects at point 1, which will be whatever is being at point Z. So in this case, Z is 1 because we have JW over Z, and Z in this case is 1. So at point 1, we have a line that's minus 20 decibels per decade intersecting it. So at this region, I'm going to extend this. Hold on. There we go. So I'll have this to be 1. And we have the following. So this is minus 20 decibels per decade, and it's represented by minus log JW. Oh yeah, and this starts at 0.1, not 0. It can start at 0.001, but not 0, because log of 0 is undefined. Okay, so that's the next part down. Now we just have this part. So at 10, we have this, and then it breaks down with a slope of minus 20. See how this one matches this one? So P is 10, so it breaks with a slope of minus 20. Also, the side note, the power also matters. So if this was to a power of 2, then it would be minus 40. And same goes for everything else, because it's minus 20 times, it's 20 times n being the power. So this one, it's minus 20. Hold on, let me draw this more. Okay, minus 20 decibels per decade. So it's minus log JW 10 plus 1. Now, our Bode function is pretty much going to be a combination of all of these. Okay, so this thing, this hits 20 here. This is minus 20. Okay, if you start at 0.1, then at point, if we have a line like this intersecting 0.1, it's going to hit minus 20. If this starts at 0.01, then it's going to hit 40. So we're doing it from here. Wait, a quick way to try and figure this out, like if you don't know where it's going to be at, this is how you figure this out. So y2 minus y1 all over x2 minus x1. We already know the slope of this. The slope of this is minus 20. x2 minus x1. So recall we're working with decades, not radians per second. So what we do is do tan inverse of the 2 points. Sorry, not tan inverse, my bad, sorry. My apologies. Log base 10 of these 2 points. So we'll put the second point here, the first point here. So that's 1 divided by 0.1. Log of that will just give you 1. And y2 is 0. Okay, so now we're just solving for y1, which is this one. So minus y1, this and this cancels out. So y1 is actually 20. So that's how you can pretty much figure this out. So we add up all the starting points here. So we only have one starting point, so 20. So we start here. Now, our line will have a slope of minus 20 degrees until we hit this region, because then we have to now start taking into account this slot. So we'll start. So we're moving this way, and then we hit here. Okay, and we can actually figure out what the exact point this will be on the y-axis. So what we do is we do y2 minus y1 all over log this point 2 all over this point 0.1 equals the slope, which is minus 20. So log 0.2 divided by log 2 divided by 0.1, that's 1.30102. So times that to this, and that's minus 26.02. Now 20 will be y1. So, and this is obviously, this is going to be y2. So y1 and then y2. So bring that to the other side. So that means y2 will be minus 0.02059. So that means this is way to not scale. So let me properly draw this. Okay, still not proper. So that must mean this must go further down. And we'll call this minus 6.02. Okay, so obviously not to scale, but whatever. So now when we continue our thing, we see our line should have, we have to add these two up, but they both have this one has a slope of 20, this one has a slope of minus 20, so they cancel each other out. So that means our line will start moving in this direction with no slope until we hit 10. And when we hit 10, obviously these two are still canceled out, but now we have to take this into account. So this starts moving in this direction with a slope of minus 20. So that's our first void plot done. So this is in HDB. Okay, there we go. Now let's draw our phasor void plot. So we have that here, and then we have omega here. Okay. So we're first for this. Let's find the functions they're related to. So this we got from this. This we got from this. This we got from this. So we're gonna be checking these plots to see what our phasor graph should look like. So JW over 2 plus 1. This is the closest that this is the closest that matches to it, and we see at its z point, which is pretty much its p point. So at its z point, when it's at z divided by 10, we break. Then we start moving at an unknown slope until we hit 90 degrees. Obviously, 90 times n degrees, n being the power, at z times 10, at point z times 10. So for us, our z value will be 2. So this will be 2, this will be 2. So this is 0.2, if I'm not mistaken. And then this is just 20. And then this is just 1, so 90 times 1, this is just 90. So that's how ours should look like. So we have 0.2. Recall we started 0.1. Then at 20. Oh yeah, and then recall this is a positive value. So that means we are going from here. Oh yeah, and then this is 90 degrees. Then we have an unknown slope up here. Then we stop here, and then we continue. And hold on, let me. Okay, there we go. And this is going to be tan inverse W over 2. Now, for minus tan inverse W is related to this one, and we see and this is negative. This is a negative value, so we're going to be working with this one, and we see its whole region. It's going to be just minus 90. So we're going to have minus 90 here, and this one is going to be minus tan inverse JW. Sorry, just W. And this is just equal to 90 degrees. Now let's see what's next. Now we have this one. It matches with this one here. So it's pretty much the same thing as this one, but just on the negative plane. So our z value for this one, for this is 10. So 10 divided by 10, that's just 1. And 10 times 10, that's just 100. So it goes from here, goes all the way to here, and then this. Now we have to find these two slopes. So to find the slope is actually easy. So we have y2 minus y1 all over x2 minus x1. But this cannot be in radians per second, it has to be in decades. So we'll do log of x2 over x1 equals the slope. So x2 will be 20, x1 will be 0.2. So at 20 we know it's 90, and at y1 we know it's going to be 0 here. So we get a slope of 45 degrees per decade. Now for our next one, it's the same thing, y2 minus y1 all over log x2, which is 100, all over x1, which is 1, equals the slope. So y2 is minus 90, y1 is 0. Now we can find our slope, and we get minus 45 degrees per decade. So this is minus 45 degrees per decade. So let me just get rid of these. Okay, so the last part of our void plot is to add up all of these lines. So uh, at the start, we have 0 here, and then we have minus 90. Add them up, we get minus 90. So we start from minus 90, and our first change happens at 0.2. So from here, and we have to increase this by a slope of 45 degrees. Okay, and then we have to stop at 1. But also, let's find at y what it should be equal to. So y2 minus y1 all over log of x2, which is 1, all over x1, which is 0.1. Sorry, not well, x2 is 1, x 1. Sorry, yeah, x2 is 1, x1 is 0.2, and then this is equal to 45. So, and then let's just bring that here. So that's 31.453. y1 was minus 90. So y2 will be equal to minus 58.546. So pretty much at this point. Now, from 1 to 20, these two cancel each other out because this one has 45 degree per decade slope. This one has minus 45 degree per decade slope. So it's straight all the way until 20. Okay? Now after that, this has a slope of 0 now, and this this is the only slope that's left, and it stops at 100. So let's find at point 100 what the degree should be. Okay, so y2 minus y1 being minus 58.546, and log of x2, which is 100 all over x1, which is 20, equals minus 45. So let's see what that gives me. And I get y2 to equal minus 90 degrees. So that means at this point, it's going to be minus 90. So this has to go all the way here, and then from then onwards, it has a slope of 0. Obviously, notice how this and this don't really match up with each other, which means it's not exactly to scale, but this is pretty much a good idea of how the Bode plot should look like.